All right. So what we did on Monday was in the Android class, we started working with sensors. So you guys have a good advantage. I think the way it gives a better understanding overall is if you see the same topics for different operating systems or different methodologies being implemented, then it improves the learning as well as it gives a perspective on how to do the same thing in both Android and iOS. Very often you will be asked to do that. Most companies, they don't create just one app for one operating system. They will have for both. So it is a good skill to have. It's easy to see both sides of the picture. So what we will do is we will in our course, that is going to be our theme. What we cover in Android in parallel, we'll try and keep them going in parallel. So what that also does is it gives us an opportunity to do more in the iOS class because all of you are in the Android class as well. So whatever we do in Android, the basics, the theory is already familiar. For example, sensors. We talked about how sensors work. You will see that the sensors are very similar in their functionality, and even in terms of implementation, there are lots of parallels. So that part becomes easier. You even if we do it again, it's like a revision. It will be quicker. So that keeping that in mind, what I did was I added a topic to today's class, which is not an Android topic at all, but we need to cover it. It's Swift UI. Is any of you familiar with Swift UI, having used it or anything like that?
Yes, I have used SwiftUI.
Okay.
It's Apple's new framework that basically just use Swift. It doesn't have any Objective-C, and it has it's mainly focused on usually building apps through the developing or it has like hard load reloading and live reloading.
Mm.
So when you build, you can always see the previews. It's faster to build the apps, and
Yeah.
the way they designed it is basically they prevent the misinformation or the between different app components. I was reading one article which said that usually like it's very common to see how the notification center if you see the app and the amount of notifications you actually have in the app, so that disconnect happens in all Swift apps as well, where you can see that I will say you have nine
Yeah.
notifications, and when you open the app you only have two or three. So with Swift UI, the way they made this network, like that thing never occurs, so the information is always linked correctly. So there's not never a lag between what's the UI is presenting and the actual information.
Yeah, so these are some of the advantages, and we'll go through, we'll, cover a whole host of things, and we'll develop an app using Swift UI today. So everybody will have not only have an idea, you'll get some experience and learn the differences between Swift UI and the way we did last time using storyboards. So that's what we'll do. I have some slides on the group project, but I will talk about it a little bit later. So what we will do is we will get started with Swift UI. So if you remember what we did last time, we created an app, a very basic. Let me open it up and put this widget demo. And what we did was there are these storyboards. If you see in the navigator here, there is the main storyboard. And this is how we designed the app. So this is our storyboard. There is a view hierarchy here. And the way we can do things here is we can drag and drop. And if we select any component and look at its attributes, we can change them here. So this is the interface builder and the storyboard way of working with things. Swift UI is it allows you to do everything in code. And if we were to compare the two, this is what the comparison would look like. So Swift UI is a more recent addition. In fact, it came out and became default last year only. Whereas doing things the way we did last time was the previous standard. And Swift UI is available with only Swift. So if you create an app, if you were to do a new app, let's say you go here, file, new project, and you choose the language as Objective-C, then you won't have access to Swift UI. You change this to Objective-C, suddenly you don't have Swift UI because it is built in purely. And I don't know if I mentioned it, but Objective-C was the the previous standard, like when Apple launched the iPhone in 2007 and then the App Store in 2008, all the apps were written in Objective-C. Swift did not even exist. So now they're starting to move away from Objective-C. They actually want to kill it. That's why new component, new things are only Swift. One big difference between the two is storyboards, you basically work in a graphical way, in a, drag and drop, what you see is what you get kind of thing. Whereas Swift UI, you can work in both the ways. Like, for example, if you were, you want to create a web page, you can code in HTML directly in a text editor, or you can use some tools. Microsoft has its own, and Adobe has to create web pages. So Swift allows you to do both. You can code it, or you can drag and drop. Whereas storyboards only graphical design. The code, there is code underlying, but it's really complex. Which brings us to the next point that Swift UI has simpler code. It's easier to read. Whereas storyboards have a complex code base that is underlying whatever you see. And what that does is that if there is a team of people working on something, then storyboards, the code that is created when you commit to your source control, storyboards can be problematic to merge because of the complexity. Whereas Swift is easier to merge, it's easier to debug. If there are conflicts, they're easier to resolve. And one other difference is that in storyboards, if you did any table view controllers, you might have used identifiers for the table cells. You guys do that in the previous term?
Yes.
Okay, so some people have, some people have not. You have had different uh, teachers, I suppose. So what happens is those identifiers you specify in storyboards, and then your code will compile even if you're using the wrong identifier in your code side. You're using identifier in the code, you're using another, and the code will compile and your app will open. But when you reach that particular view, it will crash. So those kind of problems used to happen because those things only got checked at the runtime. Whereas in Swift UI, it enforces it, it checks at compile time. So if you have a mismatch, it will tell you right then and there. So less chance of having a bug because let's say you added something like that in the previous way of working and forgot to test it. Your app will can go live and then people will report a crash. One point I also felt was that storyboards have an advantage too. It's my experience that a lot of people, in the past who took courses with me on iOS development, they really enjoyed the part of doing the graphical design. I remember some students even coming to me and saying, "Is it possible to get a job where you only have to work with the storyboards and not have to do with all the programming?" So that is something that storyboards allow. You can have a person who is a specialist in graphic design, and they can develop, design a very neat looking interface. Whereas in Swift UI, you need to know a little bit of both. It's harder to segregate. Possible, but it's harder. So this is the basically what most of the motivation behind Apple creating Swift UI is here. So what we'll do is we'll create a demo app and we'll use Swift UI. We'll learn how to add new components, how to format them, how to change the attributes, etc. And we'll work with a few different types of things. And by the end of having developed this app, uh, by the time we are done with it, you will have a good idea of how to start an app using Swift UI, how to do things like navigation and basic button actions, etc. So please go ahead and create a new app and use your first name and Swift UI app is this as your project name here. Make sure you choose Swift UI as the interface, not storyboards. I'm going to do the same here. So we'll choose single view app and language will be Swift and we'll use Swift UI. So these selections, these two should be like this. Okay, everybody up to this point? Okay. So you will see that as before, when we created using storyboard, we had almost the same kind of files. We had main storyboard. If you were to create a project using storyboards, you will get a file called main.storyboard. That is not here, and instead we have something called content view.swift. Okay, before we move on, this scene delegate and app delegate. Anybody know what the difference between the two of them is? So, like we talked about last time, delegate is basically callback mechanism. It's a listener, and apps in iOS since iOS 13, since sometime around the middle of last year, Apple added a new feature to iOS, which was to allow multiple, they call it windows, multiple windows of the same app open. So, for example, on your computer, if you have Microsoft Word and you are editing three different documents, there will be three Microsoft Word windows. In the same way, on iOS, your app could have multiple windows open. Before that, it was one app, one window. So So in those days, app delegate did all the listening because there was only one window. It did all the listening, all the app related events would go to app delegate. Now, since that change in iOS, since they started allowing multiple windows, they split the responsibilities into two parts. App delegate, there is only one app delegate, regardless of how many windows you have open. So the app delegate's job is to do things that are common to all the apps. For example, it might do authentication. Once the app delegate has authenticated your connection, you can have multiple windows and the app delegate can manage the authentication. Whereas everything else that is based, that is window by window, that is now in scene delegate. So if we go to app delegate, the functionality here is more limited than it used to be. So did finish launching with options. So here is where you might do things like, do some database updates or like I said, authentication. Things like that will happen here. And there are different events that come here, configuration for connecting. So this is where you would probably do the session. Get one one for each of the apps. So this get different. So that is the main difference. So for example, you may have like the same example, Microsoft Word, three windows. You close one of them. So that will not go to app delegate. It will come here to this one. Scene did disconnect. Like how this was in the app delegate. And instead of scene did, it might have been called did disconnect. So that's the difference. Am I breaking? Oh, how bad. Let me change my network and we'll see if it improves. Okay, is it better now?
Yes. Can you explain the scene delegate again? Because you were breaking up. You started breaking up during that point.
Okay, okay. So I'll go over it again, the app delegate. So basically, I don't know how much you caught it, so if there is any repetition, it will be there, but I'll just go over the whole thing again and please point it out in the chat if I'm still breaking up. So iOS introduced the concept of multiple windows for an app sometime in the middle of last year. I think it came with a iOS 13. And what it does is it allows the same app to be open multiple times. Like, when you are editing a Microsoft Word document, you can have three different documents that you're working on. They will each have one window dedicated to it. And the same way iOS allowed doing that. Before that, it was each app could only be running once. So those are called windows. Then, they use the term window there as well in iOS. And app delegate, what it does is it receives all the events that are common to all the windows, regardless of how many are open. So, for example, and it listens for events. Delegate, the keyword delegate in Swift is used for sort of listener, a callback mechanism. So anytime an event happens that is of interest to this delegate, it will receive a notification. So for example, application did finish launching with options. So when the application has finished launching, this event will be triggered and we can do whatever we want to do here. Like maybe we keep count of how many times the user has opened the app, or maybe we, ping the server and receive some data. If it's a weather app, you may do something here. Okay, let's get the latest weather. Things like that happen here. And similarly, other events happen. So all of them come to the app delegate. Whatever is for, regardless of which window you are on, the common functionality will be triggered here. And for each instance, each window of the app, there is a scene delegate. I can't hide the preview. Anyway, this is the code here. Scene delegate. So scene is specific to the scene, the window that it is connected to the delegate. So this receives events that are related to that particular window. For example, you have three windows open, you're editing three documents. You close one. It will receive an event in this delegate. So for example, when you close a window after it has closed, scene did disconnect. Maybe you need to clean up. While it is closing, you may receive another event, something that says, okay, it's about to close. So if the document is not saved, you can save it. If you need to pop an alert, you can pop it. Things like that. That will, all of those will come here. So that's the difference. Scene delegate versus app delegate. Any question?
How are three separate windows open in iOS or like multiple windows?
So some apps, and I can't think of an example right now. Maybe, the ones we are talking about, some of these office apps, they can, it is now allowed to for multiple instances to be running.
Like you can open that on iPhone as well?
That's a good question, Shahrukh. That's a good question. You want to find out?
Yeah, I'll do my research.
Okay. So find out, please, and maybe after the break you can share with us. So this reminds me, there was something you asked Harry last time, and I had asked if you will find out.
Yes, but I'm not sure. Because the last time is like I think it's a one line code. It's called like set to the maximum. Uh, Sorry, I forgot the code. It's like for me, it's well automatically the wage will automatically span, right? So the reason is I set up the constraint for the each image because I didn't use the image you gave because I just download some image from internet, but the image size is so big, so I have to set up the constraint. So after I set up the constraint, the app widget will like automatically just span.
Okay, okay, because you gave it that size. You set a constraint on the app widget. So even before you expanded, you click there to show more, it was already expanded.
Yeah, I think that's the only difference between my code and your code because I think in the class we didn't set any constraint for each image. I mean, for each button.
Yeah, yeah, we did not.
Yeah,
'Cause,
because when I was doing the assignment as well, so if I replace it with the 1x, 2x, and those kind of images, the images size shrank. All the images became smaller for
Yeah,
my video. So I think if you set constraint, like Harry said, that then it wouldn't happen. It will
yeah.
remain the same size.
yeah, because for that question, my answer is because for me it doesn't change. The reason is I set up the constraint, and also for the image itself, it have a high quality, so it
Mhm,
won't
mhm.
happen. Yeah.
Good, good. Everybody following? Very interesting what they're sharing. Good. Good. Thank you, guys. So that is good to know. All right. Let's look at Swift UI. So we talked about the delegates. The content view is where all the Swift UI related stuff happens. And when you are working with Swift UI, you will see that this thing gets divided into two parts. I'm going to close this so we have more in real estate here. So your code is in the left side, and this is the area where an automatic preview of whatever you're doing is shown. So right now it says automatic preview updating paused. So let's say resume and see what happens. What this does is whatever device you have selected here, I have iPhone SE second generation. This is when it finishes loading, it will basically show a live preview of whatever interface it is. So it is like what you would see in the simulator. Exactly, that will show here. That is one advantage of SwiftUI. You, as you are working, keeps, watching the changes. So this is, I, I'm going to change this to iPhone 11, more modern device. So this is our code, SwiftUI, and this is what it shows. So let's examine this. What is it? So Swift UI, okay, are you guys familiar with React Native? Yeah. So maybe you have already covered, something like that. So it is similar to that? Okay. Okay. So Michelle, React is a cross-platform way of developing apps. So basically you write one code and you can deploy it on both iOS and Android. So, and that is typically written in JavaScript. And the way it works is just, you specify that, okay, I want a text view here, I want a button here. You write the code like that. Of course, it does not have the same advantages. There is no live preview and all that. You have to keep running your app again and again. So Swift UI is similar to that. What it does is this is your content view and this is what it has in it. So this is what it says here, that there is a text view which says hello world. And if you edit this, you see the live preview updating as you make changes. This is the basic, this is what you will get any add new view controller as it used to be called. You will get it with this hello world business. And now, see earlier with, you can still run this. If you run it, it will open separately. Yeah, it is pretty neat. So if I run it, you will see that it opens in the simulator as well, and it will look just the same once it finishes loading. Right now it is still loading, and our launch screen, if you remember, it shows the launch screen, which we haven't done anything to. So it shows a white screen and then it shows the text. Okay, let's see what we can do. I want to follow the script there. Okay. So let's see what we can do. Now, if we want to add something to this, let's say we want to add a button below it or an image. What we do is right now it says the body has text in it. If I want, let's say you see, I haven't read any documentation, and I think that if I just put something here, let's say I put another text, see what happens. So there are supposedly two text views, but instead we get an error. And it says here that function declares an opaque return type, but has no return statements in its body from which to infer an underlying type. And you can Google this and find out what is going on. Okay, how about you guys do that? Take 5 minutes or Maybe not don't need 5 minutes. Take a few minutes, 2, 3 minutes, and see what this problem is. So, anybody?
So I think the problem is we have to wrap those two text view into one view and then return that. Otherwise, I think it's called like a multi. Sorry. Uh,
That's exactly right, Harry. It is
oh yeah.
expecting one single view as the return, and that's the default. Whatever view is inside is returned.
Yeah, that in SwiftUI, usually everything is wrapped in stacks, so that's why you use like 8 stack or V stack to wrap them.
So what we did was, you see, we added this, right? So let's get rid of it, and we need to wrap this in a stack. And there are a couple of ways of doing it. Basically, we can wrap it in a stack. We can, wrap it in some other view as well, whatever is the option. And how do we do that? In your preview here, any of the views that you have added, if you want to manipulate it, you need to do press command and then click on it. And you will get the menu of what all things you can do. What are the various things you can do? So this is something you'll be doing again and again if you work with SwiftUI. First option is SwiftUI Inspector. This is like the storyboard inspector. See, this shows up here. This is a text view, so it lets you change the text, font, etc. The same inspector is available to you if you open this right panel. Same as, it used to be in storyboard, except you have a fewer options here. So that was the first thing we saw there, command click. The second is embed in horizontal stack or vertical stack. So let's say if we want the next thing we add to be below this or above this, then we have to use vstack, otherwise we can do edge stack. And list is what you would use if you had a For example, this was just a prototype and you wanted to do it dynamically based on, let's say, reading from the database and populating it. You would embed it in a list and then work with lists, manipulate them at runtime. So for our case, let's say we want to do VStack, we want to embed it in a virtual stack. So I'm going to say embed in VStack, and you see what happened here. Actually, really simple. It created a VStack block and put the text inside it. And you could have just typed this instead of doing that embed. You can even type it. So, so far so good. Okay. So now we want to add the another text view to this below this. We have two options again. You can go with typing, and you should see that, okay, automatic preview updating paused. So it pauses from time to time. So you just have to say resume. And the second one should show up now. Right? The second text book showed up. That's one way of adding. Another way of adding is same as before. You open the library of objects and you drag and drop whatever you want. So if I want text, I can drag. And now I have a choice. I can drop it here or I can drop it here. So the way you prefer to work, if I drop it there, even that is fine. So this is what SwiftUI allows you to do. You can code it or you can do it graphically. It has the ability to do both. And okay, how about the customization? I'm going to get rid of this particular one, the placeholder. Let's say we want to increase the spacing between these two. So for that, it is again like how you would have done it in the storyboard. You can open the inspector and you have those same options as before, but they're a little bit simplified, easier to understand. Spacing and alignment. So spacing, if we want to increase the spacing, and you will see it being manipulated live here. So let's say I leave 16 points and I want this by default is center aligned. I could change it to left, leave it center aligned. So these are and there are some other things you can increase the padding around this object. If let's say this vertical stack it was itself was in a horizontal stack, and just like you would do in HTML or any other place where you have got some styling ability. Okay, so how about we carry on with this and add an image. Before we do that, let's change the attributes of this text. Hello there, world. You can change the font. Let's change the font. And okay, here the font is defined as a class. So basically, you can have title, headline, etc. So right now it is inherited, meaning whatever is the default in the parent, it is inheriting. But I could make this, let's say, large title. Suddenly that text would be large, whatever the defined size is, and it may vary from device to device. So you don't have to worry. On a smaller screen, lower resolution, the operating system will pick the what is the corresponding. Weighting. So this goes from normal to bold and even lighter and heavier. So if we make it bold, it will look like this. You can change the color. Color is inherited, black by default. Let's change it to red, and so on. You can play around with this, do it to your liking. And as we are doing it, interesting, see what is happening to the code. So this is the text, hello there world, that we are playing around with, styling it. And these are the what are called the modifiers. So it every time we made a change, the modifier it changed here. So for example, I don't want it bold anymore. And I have two choices. I could open that attribute thing and do it there, or I could just get rid of this. I can just delete the bold. So again, the same thing as before. You can do it in code or you can do it there. So that's any questions so far? So no questions, okay. All right. A little exercise for you. I want you guys to do two things. Add an image somewhere in this stack and add a button. And to add the image, use one of the images from last time or any image you want to use. Your job is to place it in the project in the right place and add an image to this stack. And we'll be doing more and more of this. I will be asking you to do things so you also get to explore and share how you got to how you arrived at something. So let's do that. Take like 2-3 minutes, however much you need, and we'll continue from there. So Sangini, I see that you've just joined. You might want to create a new project and use Swift as the language and Swift UI for the view design. And you will see almost what we are looking at here. And then you can make the changes to bring it up to this point. So as you do it, as you've got the image and the button, please just post in the chat saying you're done. When everybody is done, we'll resume. Okay, so those who are done, you can answer in the chat. How many of you did a drag and drop from the library of, of objects? So some of you have done that. And how many of you actually just typed the code here? Was I breaking up again? You can hear me. Okay. So I will take that as a yes to hear me. Okay. Good. So let's do it here. We want an image. Let's go with the image. So I'm going to drag and drop it here. So this here is, it's asking me for an image name. And the way we get the image is as before, we will just drag and drop the image in the assets, and then we'll be able to use the name. So where are my images? I'm going to use one of the images that we had last time. Drag and drop it here. So that's the image we've got. And now in our content view, we just use the name of that image, which is img_3 here. Should be as simple as that, right? So we've got an image. Now I want a button as well. So let's do the button. We'll drag and drop. And this time I'll drag and drop here just for variety. And you will notice that buttons are a bit special. In that button is like a wrapper around a text. And it's exactly the same even in the storyboard. Even in the storyboard, buttons have an underlying text view. And on top of that, an action is overlaid. So this is our button right now. It doesn't do anything and it just says button here. And this thing automatic preview keeps getting paused. So if you notice that, you just resume and the button should appear there. So let's change this button to say something more interesting, like click me. Okay. So now this is basically as before. You can work with this. Oh, and did you see what happened? I actually dropped the button outside the first word V stack, so it automatically created another V stack for me because I dropped it here. So my button is outside the first vertical stack. And this can happen to you. Very easy to fix in code as well. I'm going to just get rid of this one closing bracket and one the opening V stack. And that should do it. So now my button is inside that same vertical stack. Okay. Let's see what concepts we have to cover before we can move on now. So this part we did. We have learned how to add more components to your Swift UI interface, including images, buttons, and everything else. With basically the functionality, the philosophy is the same. What we want to do next is we will go into a little bit of a theoretical part of Swift UI, how it works. So we will look at something called view modifiers, and we already have some examples of that. In your view, you see whatever this dot something, these are view modifiers. But we'll now look at what are different types of modifiers and how to use them. So these modifiers can be used for things like sizing, positioning, aligning, formatting, like we did with the text. They can be used to create animations, whatever the default animation schemes the system provides. They can be used to process gestures and events, and to process actions depending upon what view it is, if it supports actions. So we'll look at the view modifiers for, and each view type has its own modifiers because some views have some functionality, some don't. And the way you access it is you'll go to the documentation of the view that you are interested in. And let's do that. I'm going to open this page. Hopefully it is going to open soon. Okay. So this is the Swift UI documentation, and if you want to see other views and controls, you can go there in these breadcrumbs, but we are on the button documentation for the button. So this is how you use it. This is how we have it. And what this means, sign in is a function that will be called when this button is tapped. There is a convenience initializer if your buttons support text and images, both, right? If you've got an image, then you can, instead of text, you can put an image in there. But if you have only text, then you can use this convenience initializer, which is basically text and then the action, the arguments. And adding buttons to containers. So these are other things that you can do. You can create a context menu, press and hold, and it appears. It can have multiple buttons. Change the style of the buttons in one go. If you have a stack of buttons, you can change the button style. What we are looking for right now is what is called the view modifiers. So we'll scroll here until we arrive at the view modifiers. So applying standard modifiers, and there is view modifiers. So let's look at what view modifiers the button class in SwiftUI it supports. So broadly speaking, you look at the categories, sizing a view, how big it is going to be, positioning, how it is going to appear on the screen within its container, alignment, padding, layering, overlaying things on top or below it, border, masking and clipping, and scale the view, rotate and transform. So all of these features, you can do it in your code. All you need to do is you just say dot rotation effect and you define it and it will rotate the view. This is a lot more power than you will find here in the, let's say we're talking about buttons. If I go here in the attributes, I can do a few things, but the code allows me to do a lot more. Well, actually, it allows me to do it right here as well. Add modifier. My screen frozen. It's not responding. Okay, to take some time. So all of those modifiers you can actually add from here as well. So in the same vein of allowing both graphical and designing through code, you have all of those things available to you here. All the modifiers. Perfect. So what are we looking for? Adjusting text, animations. So this is a very big list and you have lots and lots of functionality that is available to you and it is all through modifiers. So what we may want to do right now is, let's say I want to show an alert when that button is pressed, right? So what we are looking for is an action. I know that in this list, it showed me an alert, right? I can have an alert modifier. Let's do that. So this way, I can define an alert and show something in it. Just like a JavaScript alert. So that's one concept of Swift UI that is important to know, that is view modifiers. And the other concept is binding and state. You remember how in Storyboard, how you would connect a button, or let's say take the example of a label, which is basically text. Into your code, you would do that control drag and create an outlet. And that outlet would allow you to change the text that is displayed and things like that. That is how you connected your view to your controller, the code. For a button, you will take the same, let's say you do a control drag and you'll create an action, an IB action, it used to be called, or it is still called interface builder action, IB action. So that is what in Swift UI is done using binding and state. So what it does is it allows you to manipulate the data that is stored if you're working with it in the code from the view and have a connection. So it is kind of like storing a reference to it or a pointer to the actual source of truth. This is the keyword we are looking for. So the variable that holds for example, the value of a text field, an editable text field, it is stored in the code somewhere. But when it is displayed, there may be another place where it is, being taken to. That value is displayed in the text field through some other mechanism. But the source of truth, it knows, is in your original code. And that is what they call binding. You're binding the the information in the view to a variable in the code. This is done through property wrappers. I know this is a bit abstract and we'll see an example of it in a moment. I just want to show you what it is. So binding, a property wrapper type. Properties are basically variables, class variables, and you can wrap them. Wrappers are created by putting an at something, at property wrapper, at this, at that. So that way you're telling the compiler that this variable has a certain behavior through the wrapper. And here is an example of that. So you have this is a struct. Basically, all our Swift UI objects that we place are structs. We have one called play button, and it has a variable here declared, it's called is playing. It's a Boolean, true, false. And what it does is this here, play button, the image it shows. So for example, if it was a music player, it is going to show the pause button when it is playing. So you know that if I touch it now, it will pause. And when it is not playing, it will show the play button. Right? And what it does is every time you touch it, it toggles. So if it is false, it will become true. If it is true, it will become false. Now, where is it coming from? Where is this is playing? What is its initial value? So the way it happens is now you have another view called player view in which you are using this play button class, object of play button. And that's where you pass it this variable. So any variables that you're binding here, you will pass by name. You're saying is playing and its value. So we've got text, some text that it shows the title, etc. And then the play button. So originally its value is false. Is playing, it's got the same name, but don't let that confuse you. In here, you could have called is whatever you wanted, variable name, X, Y, Z, whatever you want, you can give that value and you will have to pass it accordingly. What is happening here is you're not passing just the value, you're passing the entire binding. You're binding it through this dollar. It's like you're passing a reference. What is happening is you're saying that this is playing variable in here. If it is changed, come back and change the value here. That is what that binding is doing. So play button receives the argument. It's a read-write binding. So it not only reads, any changes made here will be made here as well. So this is becomes your source of truth. This is where it is actually stored. And the way you tell it is by this declaration at state. It stores the state of this variable. This is a property wrapper called state. Using the at state property wrapper to indicate that this property is the value's source of truth. This is how you work with buttons to do things, one way or another. Let's say play pause is an example. We'll see one example in our case, the alert. What we want is we want to display an alert and dismiss it. And depending upon what the value is, it will either show the alert. If it's already showing, it will not. This is also a bit abstract. This was one of the things I found that Swift UI, although it allows all these things in parallel, drag and drop and code, but all of this is a little more complex to wrap your head around than the way it was done in the storyboards. Any questions, guys, here? So now what we want is we want to do something similar, right? We want to show an alert. So we will add a button which we already have. We'll declare a state variable and pass it for binding and then create the alert. So what we were looking at is to declare a state variable. This is our syntax. And what do we need the state variable here for? We want to keep track of whether an alert is currently being shown or not. So that's our state variable. We'll declare one just like this in our content view. Variable is blank. We'll call it here. It is, see, it's already asking us is presented, right? So let's do that. We'll say at state initialize it to false. So by default, it's not visible. Okay. And now the way we bind it is, you remember we put a dollar in front of it and say is presented. So now it is passing, you can say it's passing a reference to this location. And within the alert now we need to build the alert inside. Right now, should not do anything. And here, if you have built interactivity, maybe I'll show that in a minute. Let's run this in the simulator. Nothing, because the alert content is empty. So we've got to a point where we have created a state variable and we are passing it. Now we need to create the alert. How do we create an alert? We are at a point where we usually take our breaks, an hour and 15 minutes. So why don't we do this? We'll take a 20-minute break. And if any of you is curious, does not need 20 minutes, you are welcome to explore and find out how we will display the alert. If you want to, all of you want to take a break, that is fine as well. So why don't we take 20 now and we'll resume at 9:35. Okay.